Hello, everyone. So we are going to be doing chapter 7 today. I hope to finish the entire 7 chapter in 1 hour, maybe a little bit past an hour, but it is only 3 sections. So we'll see how we do. This should be a review, at least the first part of it from your algebra class whenever you took that. So maybe it will be a bit easier than the previous one. Okay, let's get started. All right, unit 7. Unit 7 is regarding lines, system of lines. Here you were talking about two-dimensional, so on a sheet of paper, what can two lines do? Let's take 2 pens, for example. Let me lock this up. Okay, what can 2 lines do? 2 lines can meet at a certain point, one single point, okay? Another one, they can be parallel, so not meet at all. Or the other one is they could be right on top of each other. And I can't, maybe I can. So what you see from a bird's eye view is basically one line when in reality it's 2, okay? So in the first case, this is one solution because they meet at one place. The next one is no solutions because they don't meet, assuming they're straight and they run parallel to each other. And this one is many solutions. When they ask you to solve a system, they're asking you to let them know how many places, at how many places do these 2 lines meet. So it's either going to be, you only have 3 choices, 1, none, infinitely many, okay? So that would be the drawing that you would make here. Solving graphically, y equals mx plus b. If you are solving by hand graphically with a graph on your own, the work that you would show would be putting it in y equals mx plus b. And then the intersection would be the solution if it has an intersection. If you are solving by hand, meaning algebraically, those are these 2. So you can use this first page for your test. So for your upcoming test, you can definitely use this. This is all steps. It has no math yet. So let's look at this first substitution method. The substitution method, in order for you to start substituting, you have to get one equation for one variable, and then you box it. I'll explain that when I do an example. Then you substitute, which is what it's called substitution. Then you substitute that box into the other equation. And you will basically have, you will begin with one equation, 2 variables. When you substitute that box, assuming you did it correctly, then there will be 1 equation, 1 variable. So it'll be solving a multi-equation, multi-step equation, but it'll be 1 variable. And then once you find the answer, so once you solve it, you plug that back into the box, which will get you the second variable. So your final answer has to be written in XY form. Make sure that you get 2 variables prior to you finishing the problem. Okay, the elimination. For this elimination to work, I think it's the easiest. You just have to make sure that these are put in the specific order. For this substitution method, it becomes kind of difficult when you solve for a variable and you have fractions. And so that's a little bit difficult. But the elimination method is always very nice and very simple to use as long as you have all your x's and y's aligned. So they should look like this: x's, y's equals numbers. That is a number symbol, okay? Not a hashtag. Step 2 is to decide which variable you want to cancel or eliminate, which is why it's called elimination. In order to eliminate a variable, the coefficients have to be opposites of each other. Opposites means same number, different sign. So 5 and -5 are opposites of each other. 2 and -2 are opposites of each other. So you have to figure out what to do to make them the same. Once you do that, then you add straight down and you will see clearly that you'll get automatically like x equals 5, whatever. And then you plug that answer into either equation to solve for the other one. And your answer, again, has to be written down in x, y form. So again, you can use this page in order for you to not have to memorize the steps. Now, if you understand the steps and you do the problems enough, then I don't think there's a need for you to have this on the test, but you can have it as a comfort. Okay, so there's quite a few problems here. We're going to run through some of them. On the side of it, I don't know if you noticed, but I did write the answer. So I'm going to do some of these, not all of them. That way you can practice on the home. Okay, let's start with this one. This one's already set up for you. And this clearly states by substitution. So I'm going to remove this. I'm going to show you the steps and do the steps one at a time. Okay. The step says, step 1, solve one equation for one variable. So this equation has two variables on the left. But this equation has already this variable by itself. That means that this is already solved for one variable. So then I box it. I box whatever is equal to. Okay. Step 2 says substitute that box into the other equation. So I'm going to take this box and substitute it in for the letter y in the previous equation. I don't know why sometimes I write my y's differently. So the first equation is now going to look like this. Okay. I basically took whatever the y was equal to and I plugged it into the other equation. That's called substitution. Once you do that, now you have one equation with one variable. So you can just do the math and solve for that variable. Okay. So I basically solved for that variable. The next one is to plug in my answer into the box. So I had this. Now this is going to go in here. So my y is going to be -3. Now I'm circling them because they are intermediate steps. My final answer should be x, y. So it doesn't matter which one you found first. There will be some times where you actually find the y variable first, and that's not your fault. That's just how the problem works out. But make sure that you don't write that number out here first, even if you found that one first. It's not who you find first, is always x, y. So the answer for this one should have been 1 - 3, and I can check. It is 1 - 3. Okay. Silent. Okay. So that is number 1. Number 2. Number 2 requires a bit more work. Okay. Number 2, we are using substitution. The bad thing about this is that if we want to solve one equation for one variable, we have to pick one and we have to make that happen. Okay, so what you're looking for when you're doing the substitution method is you are looking for a variable that does not have a coefficient on the left. So for example, this is a 1. I mean, it has it. It has it. So you're looking for a 1. This one has a 2. This one has a 2. This one has a 1. You would not want to choose equation 1 and solve for the y. Because what's going to happen is at the very end, you're going to have to divide by 2, and that will create fractions. So you would want to solve for this x right here or this one. It doesn't matter which one. Okay, let's take the first one. But it doesn't matter. So I'm going to take equation 1 and I'm going to solve it for x. That means I'm going to subtract my 2y. And these are not going to come together. They're just going to be left as they are. And it doesn't matter the order either. And then I'm going to box them. So once I solve one equation for one variable, then I'm going to box it, which is what I did. And I'm going to substitute the box into the other equation. So I use this one, right, to solve. So I'm going to substitute this in here. So I'm going to take the second equation. And I'm going to plug that in. I'm going to do it in red, just so that you can see what I did. And then I'm going to solve. Negative 4y minus 2 plus y equals 4. So that's negative 3y minus 2 equals 4. Negative 3y equals 6. Therefore, my y is negative 2. That's one answer. So I have solved for that one variable. Then I'm going to plug this answer back into the box. And then I'm going to write my final answer. So I have x equals negative 2y minus 1. And so this is now going to be here. So it is x equals negative 2 times a negative 2. 4 minus 1, which is 3. So my final answer is going to be written as the x, comma, my y. Doesn't matter which one I found first. It's the fact that I have to have it as x, comma, y. My answer should have been 3, comma, negative 2. And that should be on the side. Yes, that's correct. Okay. All right, I will let you do number 3. I believe that's a 31. Okay. And this one will be a little bit tough because you will have fractions. You can either solve for x or y or for x. I would rather this is almost done, so I would just have to divide by 9. You're just going to have fractions in the middle steps, right? In the intermediate steps. Then the answer should be whole numbers. So give this a try. Okay, let's do elimination now. All right, elimination will start off pretty easy because I've set it up that way. Okay, so let's go ahead and start with the steps. Elimination. All right, elimination says, I can't put this tape on the other side. Elimination says, step 1, find the x's, y's, and numbers. Okay, so I've got x's, y's equals number. That's already set. Decide which variable to cancel. In order to eliminate, make the coefficients for that variable opposite. So if I look at my x's, are the coefficients opposites of each other? The answer is no. So let's move on to the y's. This is a positive 1. This is a negative 1. The answer is yes. So I'm going to eliminate the y's. Okay. And so if they are ready to eliminate, all I'm going to do is add straight down. So when I add, I get 2 x's. When I add, these cancel, because y minus y is nothing. Add the 6. Then I divide by 2. X is 3. Elimination is super easy if these are already aligned and the coefficients are opposites of each other. Then you're going to plug in the answer in step 4, which is this one, into either equation. It doesn't matter. Just make sure that you do one of the original ones. Okay. So I'm always going to try to use the one that has the least amount of negatives. And that's going to go in here. 3 plus y plus 5. And then I'm going to subtract a 3. So I get y equals 2. So my final answer is 3, 2. Let me just double check. And that's how you eliminate. Yes, it is 3, 2. All right. What if the coefficients weren't the same? Okay, let's do example 2, and then we'll do example 3. Okay, so you're going to have to think a little bit outside the box. You're going to ask yourself, okay, I'm going to look at the coefficients for my x's. I'm going to look at the coefficients for my y's. Which ones can I get rid of? If I add straight down, can I get rid of the x's? No. This is a -1 and this is a 3, so they will not go away. How about this one? This is a 3 and this is a 5. If I add them, do I get 0? No, you get 8. So here you have a couple choices. You have to do some stuff. If you wanted to get rid of the y's, these would have to match. So because you cannot make a 3 or a 5 and a 5 a 3, and when you're dealing with equations, you are only allowed to multiply the entire equation by a number. You cannot add, you can't add 5 to the whole equation. The reason why you can't do that is because 5 is a constant, and 5 can add to this side, but it will not be able to add to that because that will not be like terms. So the only other legal thing that you can do is multiply an equation through by whatever number you want. So if I wanted to cancel my y's, I'd have to multiply this by 5 and this one by a -3. That way this becomes a -15 and this becomes a +15. So that requires multiplying 2 equations. However, if I decided to cancel my x's, they have the opposite sign. They're already opposite signs. And this is a 1. So it'd be much easier for me to take this equation and multiply it by 3. Make sure you do it to both sides. Once you do that, then that's the top one. You'll be almost ready to cancel. Look at that. Okay. So you purposely multiply one equation by something to make them opposites of each other, the coefficients on whatever variable you choose. Okay. So when you add down, these go away. This gives us 14y, and this gives us -14. Make sure you don't miss a negative. Divide by 14, and you get y equals -1. Once you're done, you go back to either equation, plug this back into whichever equation you want in the original equation. Don't mess with the one that you multiplied by 3 at all. I'm going to choose the first one. Doesn't really matter. -x plus 3y equals 8. That goes in here. Negative plus 3 times -1 equals 8. -x minus 3 equals 8. Add 11. Hope I didn't mess that up. And that's -11. Let me double check. This is equation 2. Wait. See, I told you we can't mess up the negatives. What did I do? Did I copy this correctly? Okay, multiply by 3. -3x, +9, +24. Oh, I know what I did. Why would I do that? You can check your answers for these at the end. You can always plug in, like, let's say I left it as a negative and -11. I could take these 2 answers, plug them into the equation, and it should work. If it doesn't, then it means I made a mistake, which is exactly what I did. That's a +3. And when I subtract, I get a 5 and then a -5. So my final answer is -5, 1. Okay. So I had put -14 when it was supposed to be positive. And I divide both sides by 14 to get a 1. I then plug in a 1 to the first equation, get a 3, subtract it, get a 5, divide -5. That is basically everything you need to know about substitution and elimination. All right, what we're going to do next is I'm just going to give you a brief overview of the graphing method, which you should already know because we already did that. Okay, and then we are going to solve by elimination and substitution some of these more complicated ones. Okay, so let's just recall really quickly. Okay, when graphing, So if you had two graphs like on the homework and they ask you what is the solution, let's check it out. We had these at the very beginning. Okay, the first one is where they meet, just one place, that is one solution. Okay, the next one is where they don't meet. So I'm going to put this little chevron. This is what these are called. And that means they're parallel. So that's no solution. And the last one, you literally just see two lines on top of each other. So that's many. It's infinitely many. I just didn't want to write down infinitely. And that's what you would have. Now, for this, okay, I'm going to quickly go over this. Let's suppose that your equations are all written in this form. Okay, so this means the following. When you have one solution, and this is on the fourth page, this is on the fourth page here of the notes. I'm actually explaining a little bit of this in a minute. The special cases would be these two cases, okay? But when you are graphing, you're going to write your equations in y equals mx plus b. In the calculator, you're going to check the intersection, and you're going to write it in xy form. So we've done the intersection of two graphs. Use second calculate intersection. Okay. Now, so when here, let's say you have equation 1. How did I write it? Equation 1. It means that equation 1 and equation 2, so let's say that's y1 and this is y2, that the slopes and the b's are completely different, okay? Like the BB1, the intersection of this line with the y-axis, this is the y-intercept, would be here. And the intersection of this one is B2, that would be down here. They're completely different, right? And the slope, one is positive, one is negative. They don't have to be opposites of each other. One could be, they could be both positive and still meet, right? They could be going towards that way, but just not parallel. They could be a bit crooked and they will still intersect. But the slopes are completely different. The y-intercepts are completely different. How about this one? Okay, so for line 1 and line 2, notice that they have different y-intercepts. So that's the letter B. However, the slopes are exactly the same. If they had different slopes, one of them would tweak and they would eventually meet. But in order for them to be parallel, the slopes have to be the same. So notice how I'm labeling them the same, but they have different y-intercepts. Okay. On this one, they have to be exactly the same line. So guess what? They're both exactly the same, M and B. Okay, that's what I have written here. Now I wrote the letters different right here, but this is the same. That's basically what it means. Okay, so when you graph, and if you have questions on graphing, we can go over that during class. All right, let's go over this one. Okay, these will be a little bit more complicated, but we can definitely do them. Now, for these, you don't know yet. I think I think that they should have put chapter 8 first and then had one of these. But this is a circle and this is a parabola. So when you go through the book, just go through what they're called and how they look like. You've got a circle and a parabola. And how many ways can a circle and a parabola meet? They cannot touch infinitely. It just doesn't happen. They can touch at one point, they can touch at two. There's certain ways that they can touch, just like the lines. And so you don't have to worry about that. We just have to solve it. So we're going to take this equation and we're going to solve by either elimination or substitution. We have to make the decision. It doesn't matter. Sometimes it's easier to do it one way versus the other. Okay, so looking at this, I already know, well, there's actually two ways of doing this, but just think about this before you do anything. I see that they're already kind of aligned. I've got my x squareds. These are not aligned. These are aligned. Okay, I got I got some stuff on mine. Now, if I were, that would be for elimination. If I were to want to use substitution, I'd have to solve. So you want to think of it in advance. You want to take this variable, solve for it. You want to move this over. You do not want to solve for x squared. X squared, in order for you to get x squared by itself, you're going to take some square roots and do plus and minuses, and that's brutal. So do not solve for x, especially if you have a square, right? So you want to always solve for the variable that's at least by itself. And if that's the case, let's actually do it. I'm going to add this. So think about what's going on. This whole thing is going to be substituted in here. And then you're going to have to square it. That means you're going to have a binomial square. So think about all the math that you're going to have to do. You're like, I don't know about that. So I don't want to do substitution. I want to do elimination. Because if I add down, these are ready to cancel. Okay, so if I add straight down, they're gone. However, these don't add, but what happens is they just literally add like this in this format. Now that is a negative. Okay, so once you have that, the whole point of elimination or substitution, whichever the case is to have one equation, one variable. Here you have one equation, two variables, no good. One equation, two variables, no good. You have to reduce it down to a single variable in order for us to solve. So now that we've got one equation, one variable, noticing that this is a square, which is a quadratic, that means you're going to set to 0. We've gone over this. We've done so much of this. This is from the beginning of unit 3. Okay, so then you have to set it to 0. Okay, and then you have to solve. Now, unfortunately, some of these you're going to have to use quadratic formula. For some of these, you don't have to. So for this example, which is pretty ugly, let's see if I copied it correctly. Equals, oh, I did it again. Why? Oh, I copied it wrong. See, I'm telling you, I copied it wrong. Sorry, it's already too late. That's a 6. I was thinking, oh my gosh, this is not factorable. We're going to end up doing quadratic. But the reason why is because I didn't copy my problem correctly. Okay. So now that it is copied, I had put a 14 when it was a 4. So 10 minus 4 is 6. Move it over, negative 6. It is set to 0 already. So now we can factor. So it's y factors of 6. That gives you 1, 3, and 2. You get a positive 3 and negative 2. So you get y equals negative 3 or y equals 2. However, these are points. So you have to know that, those are not your answers. That's just the y coordinates of 2 different points. The fact that you got 2 different y's means that this is going to be paired up with whatever x's you get once you plug this in. And this is going to be paired up with whatever x once this is plugged in. The answer is not negative 3, 2. Or 3, negative 2. That's incorrect. These two are separate from each other. They are at least 2 different points. And I say at least because you might plug in a negative 3 and end up with 2 x's. And now that y has to be paired up with 2 x's. Like you don't know. So let's go ahead and I'll take this one first and plug it into either equation. So let's just think about this. Which one do I want to do? I can actually use this one. And I had already solved this for y, so I can just plug it in here. So that's y equals x squared minus, oh, see, it's a 4. I had put 14. Okay, so then that means that if I plug this in, make sure that you know that this negative 3 is being squared completely. Okay, so I get 9 minus 4. Which is 3. Why did I change the color? So, oh. You know what? I solved for y. I was supposed to solve for x. I don't know why I would do that. Okay, yeah, I got the same thing. Okay, so I'm sorry. This y goes in here or here. But I don't know what I had done. Oh, I know what I did. I was supposed to plug it on this side and I plugged it in for x. That's what happened. So I could use the same equation. But what I would need to do is plug that in here. That's the mistake I made. So this is -3 equals x squared minus 4. I added, so I add a 4 and that's a 1. Now, be careful. When you take the square root, you already went over this, square root. You have already seen this. You have to attach a plus and minus. So you get a 1 and a -1. That means that when you take a 1 and you square it, that's the same thing as -1 and squaring it, okay? So when you do that, that actually means that this y is shared with 2x. So the way you should write this would be 1 comma -3 and -1 -3. That's the solution for this one right here. Now you have to do the same thing for that one. So we're going to do 2 equals x squared minus 4. I add the 4. And then I take the square root. Now this one doesn't have a perfect square. That's fine. So that'll still be plus minus square root of 6. So this x, these two x's are going to be going with that one y. So it'll be square root of 6, comma 2, negative square root of 6, comma 2. So all these 4 are your solution. It means that those two graphs crossed, coincided, intersected at those 4 points. Go to decimals and plug this entire thing and plug this entire thing and see how it intersects 4 times. Okay, so these are now more advanced elimination and substitution. All right, let's try the last one. We can do the 3 by 3s. All right, example 2. Y equals x minus y squared and x minus 3y equals -1. Okay, this one is already set up for you to do substitution because they've already solved the y for you. So I would go with substitution here. I would take this and just box it and plug it in here. So I get x minus 3, x minus 1 squared equals -1. Do not distribute this, okay? If you had this squared completely gone, that did not exist, yes, you could distribute the 3. But you have a squared, so you have to do binomial distribution. So you have to write it out twice. You want to FOIL this part first, and then your answer, multiply it by 3. So let's go ahead and do that. X squared minus 1x minus 1x, that's minus 2x. You guys can do the entire math for this if you'd like. I just literally cut one step. That's x minus 3x squared plus 6x minus 3. Okay, I notice again that this is a quadratic. So if this is a quadratic, I'm going to have to set it equal to 0. Notice that the left side has a -x squared. So I'm going to either move them all to the right-hand side, or I can move this one to the left and make sure I get that x squared positive. Otherwise, it's going to be a bit difficult. You never want to have to factor x squared with a negative coefficient. So we can always divide by negative, okay? So whatever the case is, I'm going to have to put some things together. So let's add the 1. And then put these two together. I'm going to bring this down, -3x squared. Put these two together. Add these two. All right, at this point, I'm going to divide by a -1, both sides. That's going to give me a 3x squared minus 7x plus 2 equals 0. Again, I want this to be positive. Now we can attempt to factor. These should be factorable. Okay, it should be factorable. So let's give it a try. 3x, x. They're both the same sign. They've got to be both negative. If I do 2 and 1, that's a 6 minus 1 is 7. So I get 3x minus 1, 0. Again, you can use whatever method of factoring you want. I just did it for purposes of this video. Right. And so when I solve, I get 1/3. Yes, sometimes you will get fractions. And this is a 2. So these are not points. Those are not the final solutions. The solutions have to be in a point format. So you do have to match your x's with your y's. And I didn't write the solutions, but it's fine. You can see it here on the video. All right. So what you want to do is plug that back into, hopefully there won't be a brutal, plug this back into the box. Okay. So we had y equals x minus 1 squared. So I'm gonna separate these. My y will be equal to 1/3 minus 1 squared. Okay, that does not mean that you're gonna have two answers in this case. This is y equals 2 minus 1 squared. So this is the one that's not a fraction. That's just 1. So this will match with that. That's 2, 1. And again, we should test this. If we were to go to decimals, we'll plug that in, plug this in, and then see where we meet. This is a parabola and this is a line. Okay. All right, here let's do the math. Y equals 1/3 minus 1 is negative 2/3. And so the y, when you square the numerator and the denominator. That should be positive 4/9. So therefore, the second answer is 1/3, 4/9. Many intermediate steps. So these two would be the final answer. It means that that parabola, which is a sideways parabola, or happy or sad face at the parabola, crossing with the line, they cross at 2 points. They can cross at 1 point, but in this case, they crossed at 2 points. Okay. All right, so this ends the substitution and elimination for the complicated problems, the nonlinear. Okay. All right, let's go on to 7.2. 7.2 is solving a system of linear equations in 3 variables. So you don't want to graph these. These are not done by graphing. This would be a bit brutal because they are 3-dimensional, and we're not going to teach you that. So the first thing you're going to do is to understand if a point is a solution of the 3 systems. So I'm going to do just one of those, and then I'm going to actually solve the system, which takes a lot of space and a lot of time, and very careful, very super careful. So let's give that a try. All right, the first thing I'm going to do is I'm going to show you this page. This is page 7. If they ask you to verify if a ordered triplet, this is now a triplet, okay, is a solution, you're going to take this triplet, this point, it's a point in space. It would have an X, a Y, and a Z. So instead of drawing X and Y, it's going to be X, Y, and Z. This is like a corner. This is like the corner of a room. Okay, so that dot would be like literally floating in space. It's hard to put the dot exactly where it would be. Okay. All right, so let's verify. So what you're going to do is you're going to take this equation, label it X, Y, Z, plug it into each equation, and see if it checks. If you find one equation in which it doesn't work, you may stop and say not a solution. So this dot has to be a yes here, yes here, yes here. If that happens, it means that that dot is a part of all those Planes, these are planes now, they're not lines, they are planes. And that dot being on all the planes means that they all intersect at that point. They could intersect at more points, but that dot is found in all those planes. Okay? And that's what we want to find out. We don't want to make it, we just want to find out if it's true or not. So first equation, second and third. Let's go to the first one. Let's plug in that x. That's a -3 minus my y, which is 6, plus my z. Does that equal -2? Don't move things left and right. You leave that alone and just do the math. So this is -9 plus 1. That's -8. Does that match the right? No, it doesn't. So right from the beginning, if I do the math, -3 subtract 6 out of 1, I do not get what's on my right. So that means not a solution. I don't even have to waste my time in trying to take that point and plug it into the other two, because it means that that dot does not satisfy all three. Okay, but I didn't have to test it in all three of them. But if it was a yes, then I'd have to test it on the second one. If it's a yes, then I have to test it on the third one. If it's a yes, then it's a solution. If any of those give you a no, it means it's not a solution. Okay, that's fairly easy. I don't want to waste my time going into more of those problems. The next part is a little bit tedious. I like the method. It's just a bit tedious. Okay, and then the last part, 7.3, will be matrices. Maybe I'll leave it for a different video, but I do want to finish at least 7.2. All right, page 9 has the steps. So again, you can use this on the exam. It is highly, highly recommended that you please, please, please use it. Unless you do lots of problems in which you don't have to, because you'll be then understanding the steps. But please, 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 if it's, you know, the first time ever seeing this, or if you can't recall it because it's been a long time, I really hope that you can use my pages that have notes to be able to go through these problems, because it's just a lot of information. It's not difficult, it's just tedious. Okay, let's go ahead and start with this. We're actually going to find a solution for this. Now you have to be super, super, super careful when writing these equations. Like if you mess up like I did earlier and you don't get the right answer, because I have it right here, you're better off starting it from scratch. Finding your mistakes in these is brutal. I'm crossing my Z so that you know it's a Z and not any other letter. Okay, so I'm going to start by labeling my equations, and I should have done different colors, but I'm just going to label them. I don't want to use too many colors right now. Okay, here are my steps. Steps 8. Take two equations and cancel one variable. So what variable do you cancel is up to you. When you decide to cancel a variable, you want to cancel a variable, just like we did the elimination process, in which the coefficients are opposites of each other. So they are exactly the same number, but opposite signs. If you don't find any, then you have to multiply an equation by something to make them opposites of each other. But these are set up in such a way that, because they're so tedious and so long, they'll probably give you some of these. So if I look up here, x's, this has a 2, this is a -1, that has a 3. It has too many variations. How about here? I have a 1, a -1, a -1. Oh, I like these. And these are all ones. But then I'd have to multiply one of these equations by a negative to make it opposite. So I'm going to choose the ones. Okay. So it says take two equations and cancel one variable. So I'm going to take two equations. I'm going to take equation 1 and 2 because those are opposites. I'm going to have to rewrite. That's why I said be careful when you're rewriting. 2x plus y plus z equals 9. -x minus 1 plus z equals 1. Okay, so I'm going to take two equations and cancel one variable. So I'm going to add down. These give me 1x. I don't need to put the 1, but I did. These cancel. This gives me 2z equals 10, and I stop. That's as far as I can go with that. So I've done step one. I took two equations and I canceled one variable. Done. Now I take another two equations and cancel the same variable. So I cannot take 1 and 3. I can take either 2 and 3 or 1 and 3. So you want to cancel the same variable. The crucial part here is to cancel the same variable when you take another two equations. If you cancel a different variable, this won't work. Okay? So I'm going to take two that are opposites. If I take 2 and 3, these are not opposites. But if I take 1 and 3, those are opposites. I'm going to write them here, 1 and 3. So that's 2x plus y plus z equals 9. 3x minus y plus z equals 9. Okay. And I add down. It gives me 5x plus 2z equals 18. And I stop. That's as far as I can go there. Okay. Now you take equation from number 1 and number 2. So this is step number 1 and this is step number 2. I'm going to take these two equations. And it says you're going to solve by elimination for a variable. So you're going to use the elimination process to solve just like you did these equations before. So you're going to basically run through this procedure. You're going to run it like you did here, like we did here, okay? So we don't need this anymore because we already know those steps for elimination. So I'm going to take those two. X plus 2z equals 10. 5x plus 2z equals 18. Okay, so when eliminating, as you already did twice already, you want to eliminate a variable, whether the x's or the z's, it doesn't matter. Notice that we don't have y's and it doesn't matter. However, the variables have to be opposites of each other. Okay, so I know that the z's already have a 2, but I don't have a negative. So I'm going to multiply the top equation by a negative 1. I'm going to do all of it. So I'm going to have negative x minus 2z equals negative 10. And I'm going to copy the red one as is. And now I'm going to add down. So basically you're doing elimination 3 times. Once you have elimination 3 times, it'll be fine after that. So I'm going to add these together. That gives me 4x. These cancel. And these give me 8. And now I have solved for one of the variables. Okay? I need an x, a y, and a z. I need 3 variables, and I've only got 1. So then I'm going to take this 2 and go back to either equation. So either of these, the one that are boxed, and plug it into either and find the other variable. So I'm going to plug it back into this one. Always go back to the original. X plus 2z equals 10. And that goes in, that goes in here. So it'll be 2 plus 2z equals 10. Subtract 2, that's 8. Therefore, z is 4. Okay. So far, so good. On here, I have put the answer. Okay. And now that I've got 2 variables, then I can go back to either of the original equations that have 3 variables, which is where one of the y's is found, and then solve. I'm going to choose the one with the least amount of negatives. That'll be the first one. And plug everything I have. So 2 times x plus the y, which I don't know, plus my z, which is 4. And I get 4 plus y plus 4 equals 9. 4 plus 4 is 8. Subtract, y is 1. You do not leave your answer like this. You will get marked wrong on Pearson if you just try to put x equals 2, y equals 4, z equals 4, and y equals 1. It just won't work. You have to put it as a triplet. So X, Y, Z. You put it in alphabetical order, not which one you found first. Okay, so it is a tedious process depending on how large you write. It took me about half a page. All right. So give the next one a try. The answer's on the side, and I gave you less variables to work with. So there is an answer to that. Give it a try. We can do it in class if you'd like. Okay. So at this point, I'm going to stop the video because I don't want this to mix to. I don't want this to mix with matrices. Okay. So this is the end of 7.1 and 7.2. Let me stop sharing. Stop the recording. I don't know if it's. All right, thank you.